Hello students, welcome to this video. In this video, we will review the topics for the first exam. We will use this study sheet to solve some questions in order to review the most important topics for the exam. Okay, let's start by the first question here. Find the solution of each system of equations. All of these questions are graphs, so we need to solve the system of equations from the graph. And we know that to solve this system of equation, let's start by number one. We need to determine the intersection point. The intersection point. These two lines here, the blue line and the red line, intersect with each other at this green point here. Okay? This is the intersection point, and now we need to write the coordinate for this point. Okay? So it's just simple one step, which is to write the solution. We only need to write the coordinate of this point. Okay, we can look here and see that each square here represents 1 unit. Okay, so each square represents 1 unit, and we have the origin point here, and of course this is the x-axis and this is the y-axis. So a point in ordered pair, okay, is just the x coordinate first and then y coordinate on the right. Okay, so we need to write the x coordinate first, and here we can see that the x coordinate, we are moving to the left of the origin, so it's negative. Okay, and how many squares did we move? Two squares. So the x coordinate for this point is -2, while the y coordinate, which is the projection of this point on the y-axis, we can see that it's only 1 square up. Okay, so it's positive and it's 1. So it's +1. Okay, we just found the coordinate for this point, for the intersection point, and this represents the solution for this system of equation. Let's try another one, this one here, the second one, okay? This is the intersection point, obviously. The projection of this point on the x-axis is 1. Each square represents 1, so its x-coordinate is 1. What about the y-coordinate? The y-coordinate is this point here, which is we can count 1, 2, 3, 4. So its y-coordinate is 4. So the solution for this system of equations is just 1 and 4. X equals 1 and y equals 4. And that's it. That's it for all of these questions. We can continue the same way. And for this question here, for number 3, we can see that there is no intersection point. And here in number 4, all of the points are intersection points. So you can check the answer key to see what do we say in these situations. Okay, let's look at questions 7 and 8. Okay, we need to write the equations for these lines in the point slope and the slope intercept form. Okay, we know that the point slope form is this one here. Okay, so let's solve number 8 now. The point slope form is y minus y1 equals m, which is the slope, times x minus x1. We need to have a point here, which is given already in the question. Okay, this point here, we can just we can assign this value here as x1 and this value here as y1. So to write this equation for this line in the point slope form, we need to just rewrite this equation again. Okay, but this time we keep the y as it is, but instead of writing y1, what should we write? We write the -1 here. Okay, so we write minus -1. Okay, and this is equal to how much? M, which represents the slope. How much is the slope? It's given to be 4. 4 times between two parentheses. This x remains the same, so we write x minus x1. How much is x1? It's given there. We assign it to be -2, so we write open two parentheses and write -2. Okay, let's simplify that. Negative times negative gives us positive, so it's gonna be y plus 1 equals 4, and we can keep the parentheses, x minus times negative 2 or minus minus 2 gives us positive 2. Okay, so this equation here represents the slope in the point-to-slope form for this line. Okay, how can we write this equation in the slope-intercept form? To write it in the slope-intercept form, we need to keep the y alone on one side of this equation. So we write y alone. What do we need to do with this 1? We need to get rid of this 1. How can we do that? It's positive here, so we subtract 1 from there and 1 from here. Okay, so we will end up by y equals 4 times x plus 2 minus 1. Okay, and we can also simplify this by writing, we can just write y equals and distribute the multiplication of 4 over the parentheses. So we can write 4 times x plus 8 minus 1. And we can simplify again. Y equals 4 times x plus 7. Okay, so this is the slope-intercept form. And this one here in the red box here is the point-to-slope form. Okay, and you can try the others to do the same thing. But there are other types of the question when we are given 2 points. When we are given 2 points like this one here, like let's go with number 14, we are given 2 points. We are not given the slope. So the first step to do is to calculate the slope. We need to calculate the slope using the slope formula here. y2 minus y1 divided by x2 minus x1. But where do we get y1 and y2 and x2 and x1? Okay, we can assign them with the points, same as the previous one, which means that we say that this point here represents x1, and if we just choose this one to be x1, then the next one to it, this one here, must be y1 also. We can't say that this is x1 and this is y2. No, they have to be the same. We can say that this is x1 and and y1, no problem. But let's just keep it like this. This is x2 and this is y2. Okay, so y2 is 2 and x2 is negative 1. So we can now substitute in the slope formula. We can have y2, which is 2, can substitute that. And instead of writing y2, we write 2 minus y1. How much is y1? y1 is negative 6. So we substitute negative 6, open two parentheses, and put negative 6. Okay, divided on how much? x2, how much is x2? x2 is here, it's negative 1. Okay, minus x1, how much is x1? As we can see here, x1 is equal to 3. So we write here 3. Okay, so how much is the slope now? 2 minus minus 6, which is actually 2 plus 6 divided on negative 4. So that's going to be equal to 8 divided by negative 4, which is negative 2. This is the slope. Now we can use this slope to substitute in the point-to-slope formula. Okay, like the previous questions before these. Okay, we can use any of these 2 points. Okay, if we use this point here, okay, we will have a point-to-slope form. Okay, let's say, well, y plus 6 equals the slope negative 2 times x minus 3. Okay, this is a point-to-slope form. Or we can substitute in the second equation to get the same thing. We will get y minus 2 equals negative 2 times x plus 1. I'm just substituting in the point-to-slope form. And you can get two forms the same as each other, but for different points. Now, If you want to just write the slope-intercept form for both of these equations, it will give you the same. It will give you the same answer for the both of these equations. Try it and try the other questions as well. Okay, we can now move on to solve system of equations algebraically, and we have just illustrate that in a number of videos. Um, let's do just a single one. Let's do number 22. We said that in these type of questions, we need to identify what is y equal to, how much is y. And we can see here which of these two equations give us the value for y. We can see that the first one gives us that y equals 3 times x minus 2. Okay, what do we need to do now is to take the value for y, this value of y, and substitute it into the other equation here. So we need to replace this y with 3x minus 2 and then solve the equation for x. Let's do it, yeah, like here. We rewrite the second equation, 2 times x plus. Instead of writing 1, you write 3x minus 2 equals 23. Did you solve this equation as we did before and before? You can watch the previous videos for, let's say, detailed explanation for how to use these type of questions. Okay. Now, writing a system of equation is a good skill to have. Let's just solve the second one. Okay, the second one, 26. Ahmad bought a total of 15 shirts and pairs of pants. He bought 7 more shirts than pants. Okay, now, do we know how many shirts Ahmad bought? No, we don't. Actually, this 15 is the number of shirts and pairs of pants. Okay, it's not the number of shirts at all alone. So we don't know the number of shirts, so we can just assign a variable for this anonymous number or unknown number of shirts. And the number of pants also is unknown. So we can just assign another variable for that, which is p. Now we know from this situation that the number of shirts and pants is 15. So we can represent this in an equation like S plus P equals 15. Okay, what about the second statement? What can we conclude from that? He bought 7 more shirts than pants, which means which one is higher in number? Shirts or pants? Of course, shirts. Okay, shirts is a greater number. It equals to how much? 7 more than the number of pants. So we can say pants plus 7 is the number of shirts. This is a system of equations that represents this situation here. Okay, we can do the first one in the same way. And for these questions here, they are the easiest questions here. If we have f of 5, we need to calculate f of 5 if we have f of x equals 3 times x minus 2. You have only to replace the x with 5. Okay, you need to substitute 5 instead of x. So you will have 3 times, instead of times x now, you have times 5 minus 2. 3 times 5 is 15 minus 2 equals 13. What about the next one here? Let's go for this one. Negative 7. We need to replace x with negative 7. So we got 6 plus 3 times x, but instead of writing x, what should we write? Negative 7. Okay, so 3 times negative 7 is negative 21. So we write 6 plus negative 21. And we can see that we can replace these two signs with a negative sign, of course. And this will be equal to negative 15. Okay, guys? And that's the same. So in each one here, we just need to replace the x with the number there and calculate it. As simple as it is. What about the following question here? The domain and range. We can see here that for each ordered pair of points, we have an x value and a y value. And this is the x value, and this is the y value. This is the x, and this is the y for each of them. Now, the range will be the values for x. Range is the values for x, which are here -3, 3, 4, 5. Sorry, that's not the range, that's the domain. The domain is the value for x, and the range is the values of y, which means 2, 8, 9, and 10. These are the values for the range. Okay, let's go for this one here. What is the domain? The domain is 8, -6, 5, and 8. And we do not just repeat the 8, we just put it 1. Okay, what about the range? The range is 4, 3, 7, and 1. And the same for all of these questions. Now, determine whether the functions are linear or not. We have a basic rule. If we have x to the power of anything other than 1, then this is not linear. This is linear. This is not linear. We have a negative power. Okay, we have a fraction power. We have a third power here. Okay, we only say that this function is linear when the x is to the power 1, only 1. Okay, so the only linear functions here are those two functions here. What about these functions here? To know if these functions represent a linear function or non-linear function, we need to calculate the rate of change, which means we need to notice what is the rate of change here? It's +1. What about the rate of change between these two? It's also +1. And here's 2, it's also +1. Okay, what about the rate of change on the y? These is +1, the rate of change, and the rate of change here is also +1, and the rate of change here is also +1. So we can say here, because the rate of change on x is constant and the rate of change on y is constant, there is a constant rate of change, which means that this function is a linear function. If the rate of change is constant, then this is linear. What about this one here? Let's try this one. The rate of change here is +3, and here +3 also, and here it's also +3. And what about these here? It's +16, and here it's it's not +13, and these are not +13 as well. Okay, so we do not have a constant rate of change here. We don't have a constant rate of change. I think this one is true. 20, yeah, I think 33 or something like that. You calculate it, but you can notice that the rate of change on the y-axis is not constant and the rate of change on the x-axis is constant. So what do we say this time? In this situation, we say that the rate of change, the total rate of change is not constant. The total rate of change is not constant, which means that this function is what is not linear or non-linear function. Non-linear function. Okay, and you can just try the other tables as well. Okay, what about these questions here? How can we say that this table represents this function? We need just to substitute this value into the x. Let's take 1 here. 3 times 1 is a 3, plus 2 is 5. So y will be equal to 5, while here it's equal to 10. So this table does not represent this function. What about this table here? Let's try 3. 3 times 3, 9, plus 2, 11. And we can examine all of the values there and see that this function here, this table represents the function. And you can also try it for the other questions as well. And for the graph, it is the same process. You need to take a point Let's say this point here. This point here represents x equals 2 and y equals something between 10 and 12. Let's take another point, a good one, like this one. If we substituted x equals to 1, we will get 5. Is that correct? 10 minus 2 times 1 equals 8, not 5. So this graph here does not represent the function. So we need to look back again to the other graphs and see which graph represents the function. Okay, now for the last type of questions, if we have an ordered pair, okay, and it asks us if this represents a point on that equation or not, we need to substitute the values. X is equal to 0 here and y equals 2. If we substituted x equals 0 and we got y equals 2, then it's a point on that graph. Okay, if not, it's not a point. Let's try this question here. Which ordered pair is a point on the graph of this one here? Okay, let's take the first one. X is equal to 0. Let's substitute x equal to 0. How we will get on y? 2 times 0 minus 2 is negative 2. Y equals negative 2. So the point is 0 and negative 2, not 0 0.0. So this one does not represent the graph. And you can continue for the other questions.